Welcome everyone. Today we're going to explore defining and calculating perimeter and area. This is the first slide, so I want to warmly welcome you all to this session. The title of our presentation is Defining and Calculating Perimeter and Area. Throughout this presentation, we'll cover what perimeter and area are, how to find them, and why they are important. So let's get started and dive into these fundamental concepts. Let's take a look at what's coming up in this presentation. First, we'll explore how your family can figure out how much fencing they need when putting up a new fence around your home. We'll also discuss the perimeter of a square and how to find it. Next, we'll consider how your parents can determine how much carpet to buy for your room by understanding the concept of perimeter. Then, we'll practice finding the perimeter of various figures using the formula P equals 4 times the side length for squares, and more general formulas for rectangles. We'll also cover how to find the area of different shapes, starting with squares, using the formula A equals S squared, and rectangles using A equals length times width. Throughout, we'll see how to connect perimeter and area concepts to real-life situations, like putting up fences or buying carpet. Finally, we'll check our understanding by practicing finding both the perimeter and area of different figures, ensuring we grasp these key concepts thoroughly. Remember, understanding how to measure the boundary and the space inside shapes is essential, whether you're planning a project or just solving everyday problems. When your family decides to put up a new fence around your home, one of the first questions you'll have is, how much fencing do we need? Well, that's where understanding the concept of perimeter comes in. The perimeter is simply the total length of the boundary around a shape, in this case, your yard. To figure out how much fencing you'll need, you need to measure the distance all around your yard. Think of it like walking along the edge of your property and keeping track of how far you go. By adding up all those measurements, you get the perimeter. So knowing how to find the perimeter helps you determine the exact amount of fencing material you'll need, avoiding shortages or excess. This idea of perimeter isn't just about fences. It's a fundamental concept in geometry that helps us measure the boundaries of any shape. And understanding it helps us plan and visualize projects effectively, connecting it to the bigger picture of how geometry applies to real life. Let's talk about the perimeter. The perimeter of a figure is simply the distance all the way around it. Think of it like walking around the edge of a shape, how far you'd go if you traced the boundary. This concept is really important because it helps us understand the size of a figure in terms of its boundary length. Whether you're working with rectangles, triangles, or more complex shapes, calculating the perimeter gives you a clear idea of the total distance around. So remember, the perimeter is about measuring the boundary, and it connects to our overall theme of understanding the dimensions and properties of different shapes. Today, we're going to talk about the perimeter. The perimeter is essentially the distance around a shape. To find it, we add up the lengths of all the sides. Think of it like walking around a fence. You measure each side and then add those measurements together to find out how far you've gone. This concept is fundamental because it helps us understand the size of a shape's boundary. Whether we're working with rectangles, triangles, or more complex polygons, the key idea is the same. Sum of the side lengths gives us the perimeter. Remember, the perimeter is all about the total length around the shape, which is a useful measurement in many practical situations. All right, let's take a look at slide 6. Today, we're focusing on finding the perimeter of different figures. As you can see, there are several examples labeled A through D. For figure A, the perimeter is not given, but based on the measurements and shape, you can practice calculating it by adding up all the side lengths. Moving to figure B, the perimeter is 24 meters. That's straightforward. You just add all the sides, and in this case, it totals 24 meters. Next, figure C shows a perimeter of 39 millimeters. Remember, when working with different units, like millimeters here, always keep track of units to ensure your final answer makes sense. Finally, figure D has a perimeter of 21 centimeters, and in the last one, we have 26 inches. The key takeaway here is that perimeter is all about adding up the lengths of all sides of a figure, regardless of the units used. Understanding how to find the perimeter helps us measure and compare different shapes accurately, which is a fundamental skill in geometry. So, as we continue, keep practicing these calculations across different units and shapes. Now, let's talk about the perimeter of a square. A square is a special kind of shape with 4 equal sides, which makes calculating its perimeter straightforward. To find the perimeter, you can simply add up all 4 sides. But there's an easier way. Since all sides are equal, you can multiply the length of one side by 4. That's why the formula for the perimeter of a square is P equals 4 times S, where S is the length of one side. This concept is really useful because it helps us quickly determine the total distance around the square without having to add each side individually. Remember, understanding this formula connects to our overall theme of calculating perimeters for different shapes efficiently. All right, let's look at how to find the perimeter of squares using the formula P equals 4 times S, where S is the length of one side. This formula is really handy because it gives us a quick way to calculate the total distance around a square. Now, for example, if we have a square with a side length of 9 meters, we simply multiply 4 by 9, which gives us a perimeter of 36 meters. That's what the option B is showing us. P equals 36 meters. Similarly, if the side length is 5 centimeters, then the perimeter would be 4 times 5, which equals 20 centimeters. That's option D. And if the side length is 7 inches, then multiplying 4 by 7 gives us 28 inches, just like option C. Finally, if the side length is 11 millimeters, then the perimeter is 4 times 11, which equals 44 millimeters. That's option E. So the key takeaway here is that by knowing the length of one side, we can quickly find the perimeter of a square using this simple formula. It's really all about understanding the relationship between the side length and the total perimeter. Let's talk about the perimeter of a rectangle. A rectangle is a figure with 4 sides, right? And an important thing to remember is that opposite sides are equal in length. This makes calculating the perimeter a bit easier. To find the perimeter, you simply add up all 4 sides. But since opposite sides are equal, there's a quicker way. You can add twice the width plus twice the length. This leads us to the formula for the perimeter, which is P equals 2 times the width plus 2 times the length. Understanding this formula is key because it connects to the overall theme of understanding shapes and their properties. It shows us how the dimensions relate to the total distance around the shape, which is what the perimeter measures. All right, let's dive into calculating the perimeter of rectangles using the formula P equals 2 times the width plus 2 times the length. This formula is fundamental because it helps us find the total distance around the rectangle, which is crucial in many real-world applications. Now, when we look at the options, we see different measurements, such as 30 centimeters, 28 meters, 54 millimeters, and 28 inches. The key is to understand the units and how they relate to the dimensions of the rectangle. Remember, to find the perimeter, we need the measurements of the width and the length first. Once we have those, we multiply each by 2 and add them together. Connecting this to our overall goal, being precise in measurements and calculations, this skill is essential whether you're working with small objects or large structures. So, keep practicing the formula, and you'll be able to quickly determine the perimeter in any unit of measurement. So, let's consider a common situation. If your parents want to put new carpet in your room, how will they know how much to buy? Well, the first step is measuring the space. They need to measure the length and the width of the room to find the total area that needs carpeting. Once they have those measurements, they multiply the length by the width to get the total square footage. It's important to be accurate here because buying too little means they'll have to get more later, and buying too much could be wasteful. This process highlights a key point about measurement. It's essential for making informed decisions. And this idea of measuring accurately ties back to the overall theme of the presentation, which is about understanding data and applying it thoughtfully in everyday situations. So, in essence, knowing how to measure correctly helps your parents choose the right amount of carpet, saving money and avoiding headaches later on. Now, let's talk about the area of a figure. The area is basically the amount of space that covers the surface of a closed shape. Think of it as how much surface you'd need to cover that shape with paint or wallpaper. It's measured in square units, which just means units multiplied by themselves, like square inches or square centimeters. The key point here is that the area tells us the size of the surface itself, not just the perimeter or the outline. This concept is fundamental because understanding how to find the area helps us solve real-world problems, like figuring out how much material we need to cover a surface or how much space a shape takes up. Connecting this to the overall theme, knowing about area helps us better understand geometry and measurement. It's a building block for more advanced topics, so grasping this concept is essential as we move forward. Remember, the area is all about the surface coverage, how much space a shape claims on a flat surface. Now let's talk about the concept of area. A square unit is a measurement that has 4 equal sides, which means it covers a perfect square shape. When we measure area, we're essentially looking at how much space something takes up. For metric units, we say units squared, like centimeters squared, written as cm2. This helps us understand the area in metric terms. In the US customary system, we usually say square units, such as square inches or SQ. This terminology is common when working with measurements in inches or feet. The key idea here is that, whether you're using metric or customary units, the concept of squaring the unit helps us clearly communicate the size of a surface. Understanding these differences makes it easier to compare measurements and ensures we're all on the same page, no matter which system we're using. This is an important part of grasping how we measure and describe space in various contexts. Let's talk about the area of a figure. The area is essentially a way to measure how much space the surface of a shape covers. To find it, we look at how many square units it takes to completely cover that shape. Think of it like covering a tabletop with tiles. Each tile is a square unit, and the total number of tiles needed tells us the area. This concept is fundamental because it helps us understand the size of different shapes and how they compare. Whether we're working with simple squares or more complex figures, calculating the area gives us a clear idea of their surface size. And of course, understanding area ties into many practical applications, from architecture to design. So, grasping how to find the area is a key step in mastering geometry and applying it in real life. Now let's look at slide 15, where we focus on finding the area of these figures. As you can see, there are several options labeled A, B, C, and D, each with different area values. The key here is to understand how to determine the area of each shape accurately. For example, figure A has an area of 16 square units, while figure D's area is 30 square units. Notice that the areas vary quite a bit, which highlights the importance of applying the correct formulas and measurements for each shape. When solving these kinds of problems, always remember to check the dimensions carefully and use the appropriate area formulas. This exercise ties into our overall theme of understanding geometric properties and developing precise calculation skills. So, pay close attention to the details, and you'll be able to find the correct areas confidently. Now, let's talk about the area of a square. The area is essentially how many square units it takes to cover the entire surface of the square. Think of it as measuring how much space the square occupies. You can find this by multiplying the length of one side by itself, since all sides of a square are equal. This means if you know the length of a side, you just multiply that number by itself to get the area. Multiplying a number by itself is called squaring it, a key concept here. So the formula for the area of a square is written as A equals S times S, or simply A equals S squared. Remember, this approach makes calculating the area straightforward once you know the side length. This idea connects to the overall theme of understanding geometric measurements and how simple calculations can help us find important properties like area. Now let's look at how to find the area of these squares using the formula A equals S squared. This formula means that if you know the length of one side of the square, you just need to square that measurement to get the area. For example, if the side length is 4 centimeters, then the area is 4 squared, which is 16 square centimeters. Notice that the slide gives us different examples with various units. We have 16 square centimeters, 81 square feet, 25 square inches, and 49 square meters. The key point here is that no matter what units we're working with, the process remains the same. Just square the side length to find the area. This is a really useful concept because it applies across different measurements. Whether you're working with centimeters, feet, inches, or meters, the principle stays the same. Recognizing the units is important so we can interpret the area correctly. Remember, the main takeaway is that the area of a square is always the side length squared, and this formula helps us easily calculate the area for any size square in any measurement system. Now let's talk about the area of a rectangle. The area essentially tells us how much space the surface of the rectangle covers. Imagine laying tiles over a surface. How many tiles would you need? That's what the area measures. You can find this by counting how many square units fit inside, but there's a quick way to calculate it too. If you know the length of the rectangle and its width, you just multiply those two numbers together. So the formula for the area of a rectangle is simply A equals L times W here. A stands for area, L for length, and W for width. This understanding is important because it helps us measure and compare spaces efficiently, which is a key part of understanding shapes and their properties in geometry. All right, let's look at how we find the area of these rectangles using the simple formula A equals length times width. So, for example, in part A, we have an area of 77 square inches. That means if we know the length and width of that rectangle, multiplying those two measurements will give us the total area. Moving to part B, there's an area of 48 square feet. Again, just applying the same idea, but now in different units. For part C, the area is 24 square centimeters, which is smaller units, but the process remains the same. And finally, in part D, we see 140 square millimeters, even smaller, but still just length times width. The key point here is that no matter what units we're working with, the fundamental idea is multiplying length by width to find the area of a rectangle. This concept ties into the overall theme of understanding how to measure and compare different spaces accurately. All right, now let's check our understanding. We're asked to find both the perimeter and the area of this figure. Remember, the perimeter is the total distance all the way around the shape. It's like measuring the length of a fence that surrounds it. In this case, the perimeter is 28 meters. Next, the area is all about how much space the surface covers. Think of it as the number of square units needed to cover the entire figure. For this shape, the area is 48 square meters. These concepts, perimeter and area, are really important because they tell us different things about a shape. Perimeter measures the boundary length, while area measures the surface space inside. Connecting this to our overall theme, understanding these measurements helps us solve real-world problems involving space and boundaries. So, when you see a figure, always ask yourself, what's the perimeter? And what's the area? This way, you get a complete picture of the shape's size and boundary.